So, a very warm welcome to all you Druids that are joining us on our fourth virtual Druid Summit, which I have to say is the only big data conference where pants have been optional from the get go. So, my name is Rachel Podreski. I run the community program here at Imply. So, many thanks to the people who have already spoken today and earlier this year. So, if you're just joining, please sure to check out some of the recordings, and which will be sent out to all the participants later in the week. We just heard from Sharanya and Tinanyu from Lyft. And it's with a very great pleasure that I introduce our fourth session speaker, who is Daniel Hernandez, who's a senior software engineer at Innowatts. He'll be presenting, analyzing, not electric, but energy meters using Druid. But before that, a couple of rules, some housekeeping notes. All you attendees will be on mute throughout the session, but that doesn't mean you can't ask questions. So down there at the bottom of your screen, there's a Q&A icon. Push that, ask questions. I will make sure that your questions get answered either live at the end of this session if we have some time, or in a follow-up blog post. The links to the full presentation and accompanying slides will be sent out following the session. We always get somebody who asks about that, so no worries. If your internet drops, they will be there for you. And they'll be live tweeting throughout, so be sure to follow us on Twitter. Anyway, enough with that. Welcome, Daniel. Over to you.
All right, so today's talk, I'm going to go over how at Innowatts we use Druid to analyze energy meters. I originally labeled my talk electric, but we're also in the non-renewable space, so that's solar and wind, and we're also in the gas market. So everything that I'll talk about today is completely applicable to those energies as well. But the examples I'm going to cover today are going to be more guided towards electric, since I'm a little bit more familiar with that, a little bit more comfortable talking about it. All right, so basically some agenda of what I'm going to cover today. I'm going to start off with what Innowatts does, just so we can see at a glance where we sit in terms of your electricity provider and what we do. Then I'll talk about the motivation of actually going with Druid. And then I'll speak to some challenges that we faced along the way, some challenges that question whether or not we should go with Druid, should we go with something else? And then I think my favorite part would be the use cases, mainly because Druid is typically just used for, or the main reasons why it's used is for like clickstream data or like telemetry data or things like that, but it can also be used for forecasting. So that's pretty exciting. I'll talk about some internal use cases and some external use cases, how we use Druid at Innowatts. Then I'll go over some architecture on where Druid sits in the grand scheme of things, and some learnings that we learned at Innowatts, both the hard way and the fun way. And then a roadmap of where we plan to go with Druid moving forward. So let's get started. So I think this picture best describes Innowatts at a glance. And the reason why I went with electric with the initial presentation was it's the easiest one to understand. So for all you Druid users, I'm assuming that you guys have electricity. And if you guys have electricity, you have a meter in your house or your apartment complex, or even where you work, there's some electric meter sitting there. And what Innowatts does, it's not in the space of generating electricity, so we don't do any generation. But what we basically do is we take that energy, that meter data, we create a unique energy footprint, and this is what is the foundation for all the products that Innowatts offers, and we call this core analytics. So when I say footprint, what that basically means is we take that meter, and then we analyze like your lifestyle, how your electricity consumption is affected by weather, things that you do during the day, so timing. So for example, we can tell with good accuracy if you're a household that has that goes to school, because obviously whenever your kids go to school or you go to school, there's a spike in energy consumption, and then there's a complete drop until school ends. And then we can also tell that by looking at your energy consumption during those summer periods and those holidays. So we'll see that normally when you would have a drop in energy during like a school day. During those off school days, we can tell, oh, you have some kids in your house, or they're not actually going out to school and things like that, or it's part of your like job. We can kind of tell those kind of things off of it, and that feeds into the decisions we make when we're creating a forecast, which is what I'm talking about today. Grid edge management, load scheduling, I'll touch on it a bit today as well, and product management. Um, so on to the next slide. So the motivation, what actually brought us to Druid. So we've been working with Druid since officially at Innowatts since the beginning of this year. Unofficially, it was more of like a let's do something fun during a Christmas break kind of motivation. We wanted to see, can we make Innowatts product better? So to give you some history, before we even used Druid, we were basically pre-aggregating forecasts using like EMR clusters to run Spark jobs. And what that meant was we weren't really showing our clients, which would be our retail energy companies, um, or people that purchase load on the market. We weren't showing them meter level data. We were showing them was their preferred aggregated view of it, and that was fine at the time because that was what we were initially aiming to do. Provide insights into how much energy they should purchase. But as that meter portfolio was growing, so it's growing, it's above 40 million meters right now at the moment. We wanted to provide the insights that Innowatts has onto our clients. So one of the reasons why we're really great at load forecasting is because unlike other competitors or energy industries, we create a bottoms up forecast. So what that means is we create a forecast based on that energy footprint that I mentioned in the beginning. Um, our other clients, what they used before mainly is they would create a forecast from the top down. So they just look at how much they use at the market, and then they'd use either like a market down approach, or they look at their portfolio and then just make estimations. So part of the reason that why we're so great at creating a forecast is because we actually get that meter, and then we create a forecast for each individual meter out there, and then we aggregate that up. And we wanted to give that functionality off to our actual clients. So it is possible to pre-compute every aggregation. Like I said before, that's what we did. Our clients would tell us we want to aggregate by a zone or by like a geographical region, a zip code, and things like that. But ad hoc aggregation would have been a game changer. So during the holiday break, a few of us had this idea of what if we can to our clients provide like really fast aggregations, and then what could they possibly do with it? That what kind of products can come out of it, and things like that were the main motivations out of it. Um, but part of the issues as well was new clients introduced new columns. So what that meant was we couldn't really go with like a SQL based approach, because every single time we would get a new client, even though it's like the same electric meter, clients have like their own way of processing their meters. So they would introduce new columns, and we didn't want to just go with like a SQL based solution, like a standard SQL based solution that every single time we got a new client, we had to update our schema. So Druid really provided us a way to like not have to worry about that. It automatically detect new columns, and it really removes that bottleneck of having to configure like a new model for that client. And then another reason was it provides a way to aid our internal business innovation teams. So before this diagram, we're still use this diagram is like a high level view of what how things come into our system and how we output it. So basically, our clients will drop data onto like a FTP, and that's synced to our S3 buckets. And then we post process it, we clean that data, we fill in some holes, we provide some secret sauces where our actual like AI is introduced, and then we output it to our clients. So we still follow this approach, But before, the problems that would arise was onboarding a client meant that we would really have to get involved in every single step, and every single step required a lot of work. So, for example, we would load data onto S3, but then we had to create like Athena tables on top of it so we can query it and start making sense of it because our clients, either they provide the data directly or they just pass us the data from a vendor. Uh, their data doesn't always make sense, or like their columns are not like in a like where you can just look at it and see, oh, this column means this. So we would have to like go in and see like what does our data look like. And then in the post processing, we also had to create Athena tables off of it just to check, um, you know, does our backfilling look correct? Did we miss anything? Does this look right to our client? And things like that. And then the output would be measuring actually after our secret sauce has been applied, was it a good forecast? And then at each step of the way, it would circle back to let's fix this post processing, or let's ask the client what this data means because we don't understand what this column means. Because sometimes it's a hash value, or we have to go to like a different mapping table to understand like what the column means because that's how they provide the data for us. So each step of the way, you can see that we would have to go back, create an Athena table, and then export that data out to CSVs just because our data scientists like to visualize that like on their own machines using either Excel or like run it on like using something like PySpark like on their like workstations. Um, so that actually introduced some challenges. So moving to this world where we want to provide our clients meter level data proved a bit difficult when picking out a solution, mainly because clients, if we're going to give something to the client, it has to be fast. Um, because we go off of this notion of if the client has it and it's not fast, it might as well be broken because they need to be able to create insights really quickly off of that data. But at the same time, it needs to be tokenized. So that means it has to be secure. We're in different markets. So what that means is our clients really don't want that PII data to get out there. So whenever it enters our system, it has to be tokenized. Um, and we have to make sense of it as it's going through each of the steps. The next thing that was a problem was the size of the data that we were actually ingesting was pretty large, and it's in batches at like a known cadence. So what I mean by that is our clients provide us that data like a few hours before market opens, and then within that small window of time, we have to take that data, process it so we can clean it out, backfill any data, create a forecast off of it, and then ingest it into Druid. And all this has to happen in a very small window of time. So the ingestion and the analytics has to be fast in order for our clients to make financial decisions off of it. So they'll look at that data and they'll say we should purchase this amount of power, and that's what load scheduling is. So you can think of it like purchasing like stocks. Analysts will come in, will look at like the forecast, what they perceive the value of how much energy they should purchase, and they make a decision based off of that. And all that has to happen really fast. And this also led to another problem, which was okay, ingestion is fast, but the analytics has to be fast as well. So the main traffic that we see in our platform happens during market hours because they have to make those decisions as close as possible to before they can like actually purchase power. And if there's anything that arises that doesn't look correct, they could contact us and we could fix it. So all that has to happen really fast. And their queries that they're making, they have different styles and different way because they're also managing risk. So we don't know ahead of time what they're actually looking for. So it's great that we're actually providing meter level data, and they can aggregate at their own discretion. The last thing, and I think this is the most important bit, or one of the key things for me was development should be easy. This is often overlooked. So most of our teams, and this goes for most companies, is uh, they don't really want to go through SQL because it's really hard to code in. Like, so we want to have like a wrapper around it. So Plywood, which is an open source library by Imply, provide us a easy way to just basically provide like a JSON and just get like an optimized query that Druid will understand and turn into like and actually return a result. But at the same time, we also wanted to have standard SQL based tools that we could use for our internal teams, be that product owners or data scientists or anyone that just knows SQL that wants to analyze that data. So I had to have a mixture of both. Now to the fun bit. So use cases internally. At each step of the way, this is the same picture, but instead of thinking about each one of these arrows having like an Athena process that like an analyst will look at, make queries against, and then make decisions off of it, all we have to do is create an ingestion spec, push it into Druid, and we have a variety of visualization tools available to us so they can um, query it, be it through Pivot, Superset, Tableau, or they can use some of the drivers that are available. Um, so that's what makes it great at the raw stage, and then the post processing stage. It's now easier to sanity check it because there's not this step of pushing it onto Athena, creating like a schema out of it, and then exporting that onto a CSV, or they would create like an Excel file out of it so they can create visualizations, or using something like QuickSight, which is an AWS service that allows you to create visualizations out of it. Um, it's not as fast as Druid, so we can find things out a lot faster, and then through all these different tools, we actually have like different ways of actually seeing gaps and seeing some anomalies. So some anomalies that we will see is, does the client provide us an extra hour during those daylight saving times, or are hours missing during daylight saving times? How do they handle like nulls and things like that? Do they even handle nulls? So those are the kind of things that we can see using Druid and using all these visualization tools. And lastly is the outputs. So outputs are basically what the client sees, and they're using this concept called MAPE to judge our forecast. So they're basically trying to see how accurate is our forecast had we actually produced the forecast with actual weather. So part of those Druid queries, one of the reasons why we liked it, um, and why we went with Druid versus like a time series database, is because we can actually do more complex like computations while doing splits on dimensions on like non-time series attributes. Um, and then for an external use case, how we used it, um, and this is I think our coolest picture that I can have is this is our platform. So like I said before, data gets loaded into Druid. We provided this visualization tool, um, and then our clients can basically, whenever they come in, like I said before, they have a variety of filters that they can filter by, and all of this is like determined based on those columns. So before, where we had to do a lot of engagement with the client and then with our engineering team to decide how would this impact our schemas, Druid automatically picks those up, and all we have to do is just talk with our clients to see what actual columns do they even want. And there's no like intermediate step of having to do this back and forth with our engineering teams. How do we modify your schema when anything break for other clients? So this provides us an easy way of doing that. Um, and it also allows the clients to um, see different results. So we provide different forecasts for our clients. So we have different models or different styles of aggregation. So we have system forecast and things like that, and they can decide. They can look at our platform and see, based on this kind of day, like during this time, out of these 5 forecasts that I have, this forecast always beats out the other ones on this specific kind of day, and they'll make a decision based on that. So, um, Druid allowing the clients to be able to do all these computations really fast really opens up like a whole avenue for what we can do. Um, Next is our architecture. So where does Druid actually sit? So Druid fits right here in this box in the bottom right corner next to Redshift, MySQL, and all of our other microservices. And one of the reasons why we also went with Druid was because it was very easy to understand from like based on like MySQL and Redshift. We had familiarity with how SQL works with Druid, so it was easy for us to like bring it on board and deploy it. And it fit really well with everything that we had. One of the only issues that we ran into was the way we output data onto S3 is using Delta Lake. So there isn't like an out of the box um, uh, connector that can read like Parquet Delta Lake files into Druid. There is a Parquet extension, but Delta Lake has like this meta information on top of it. So one of the things that we're working on, or we plan on working on in the future, is putting like a Delta Lake to Druid connector, or um, maybe if it's even better, just directly loading from Spark. But that requires like a lot of engineering work and a lot of understanding of creating that schema. Um, so and at the beginning of the presentation, I mentioned that data comes in batches at a known cadence. Ideally, what we want to do is at some point is to have an architecture, which we do and it currently works, is that we can take meter level data directly from the source, like IoT, and actually ingest it through our process. There isn't currently a need for that, like a business need for it to do that yet. But at some point, we plan on doing that, or it may come up. So we want to be prepared for that. And the fact that Druid can handle like Kafka streams or any kind of streaming data is it's a game changer. So that's also one of the reasons why we went with Druid and not with another kind of database. It out of the box provides like a Kafka connector, so that really helps us out. And like I said before, we have as soon as data comes in, it gets tokenized, and then within this space, all this gray area, we have different tables that we can use lookups for to join that data with Druid, with some of the Druid data sources that are there, so we can provide like better results to our clients. And then should they want to like create go back to like whatever the tokenized data is, they can do that at the presentation layer, which is great. Some learnings, and I think this is like my favorite slide, is finding the sweet spot. So Druid has great documentation. One of the things that we found that we kind of pushed against, maybe because we're using Druid in a different kind of way, was this max rows per segment versus segmentation size. I think in the documentation, we saw that we should aim for 500 to 700 megabytes for segmentation size and a max row of 2 million. What we actually found out is it's actually max rows per segment is, at least at Innowatts, is king. So that's what we should try to aim for. And it's easier to plan for. It's harder to plan for like going for like segmentation sizes than it is to like specify go with 2 million rows or go with 3 million rows. So it's easier to think about whenever we're thinking about max rows per segment. And some of the things that we found as well was small segments actually lead to a lot of overhead. It may not lead to, so initially it didn't lead to overhead because we were just loading like a test case like back in December. But as soon as we started doing like these daily ingestions every day, and as that data source grew, it actually became a lot slower. Like our we see like 700%, like sometimes even more slower queries just by ingesting a lot of data. So we looked at the S3 at the deep storage and looked at S3, and we started noticing that the deep storage was getting really big. And then looking at like the docs and some of the source code, we noticed that the reason why it's happening is because per each segment, there's like an index and a dictionary, and that leads to like a huge footprint. So finding that like it should be large, we shouldn't be doing small segments, it should be large. So we went from like one extreme to like the next one, which is what happens if the segments are really large, like does it break? And we found out it didn't actually break. Nothing really bad happens. It's just you just don't get advantage of that parallelism, which is why you go with Druid in the first place. But it's okay sometimes. So when I say it's okay sometimes, during those off-peak hours, like if you're doing reporting, it's okay to like bring down your cluster size, like scale it down, um, because it doesn't really need to happen sub-second. But during those peak hours, during when market's open, it's important that that cluster is taking advantage of that parallelism. And that happens by the number of CPUs that are available. So if you have a lot of CPUs and you have really large segments, so there's less segments than the CPUs available, um, then you really can't take advantage of that parallelism. So you have to find that sweet spot. And it's something that we monitor based on like as the data source grows over time, and as we add more columns to our data, we're really looking at this figure. And then lastly, roadmap. I touched on some of these on where we're going moving forward. One of them is, like I said before, working on Delta Lake Parquet extension, maybe also considering writing directly to Druid using Spark. But we're also interested in transitioning away from batch to stream. So we already have this in like our non-prod available, but there's no client that really needs us to do that to push that into production. But we really want to be prepared for that step. Should we ever like go into that avenue? We're also looking into how to auto scale the cluster manually. That's what we're currently thinking about doing it now. So during those peak times, bringing that up, and during those peak query times, also bringing that up, and then during those off hours, just scaling it completely down, just so it could be fast enough for the clients to use, but not a whole bunch of people are concurrently using it. So that's one of the things that we're currently working on. Um, and then another thing is transitioning away from Plywood to SQL for our Druid API layer. And the main motivation out of this was we basically just wanted to get like speed to market really, really fast, like actually have Plywood available allowed us to cut development time by a lot. But we know that implies moving away from using Plywood to SQL. So we also want to follow along those footsteps. And we don't want to use a library that may be deprecated as new versions come out and new functionality comes out. And also because this SQL, using SQL allows us to take advantage of like joins that are now available that I don't think are currently available in the latest release of Plywood. Maybe they're working on it, but we really want to be prepared for that SQL transition. And that is it. I hope I answered a lot of questions and showed a good presentation on how you can use Druid for things outside of like telemetry data or clickstream data. And I want to thank the team. There's a lot of people that have their hands involved in this project, so it's great that I got a chance to present.
Thank you so much, Daniel. Spectacular presentation, and what a great use case. Very applicable to our daily lives right now. I always think to myself, how does the energy change with the whole pandemic? And I'm sure you have all those answers.
They do actually have those answers.
Very cool. So we have 2 questions currently in the Q&A. So if anybody else has any other questions for Daniel, please put them in the Q&A panel down at the bottom. First off, does avoiding pre-aggregation lead to larger number of segments and need for compaction on historical nodes?
Good question. Actually, yes. So, yes, we do have some compaction that we're doing, mainly because whenever we're ingesting data, we want the latest data to be, we also are updating the data. So based on those segments, how we partition them, being by day or by week or by month, whenever we update those segments, it's better to have like a smaller size. So our compaction rules that we set are for like like really old data, like historical, like really, really in the past. They actually have a higher segment granularity size that we use. And then as time goes on, we actually have smaller segments. So that's some of the things that we play with.
Excellent. And can you talk a little bit more about how you automate your batch ingestion? So what are the biggest challenges you've run into? prior to transitioning to streaming, and how did you resolve them other than moving to streaming?
Okay, yeah. So we use Airflow. So part of the automation is just using Airflow. But for each different stream of data that we have and different clients that we have, um, we can basically create like a configuration spec, like using the same word that Druid uses. Um, we just create like an easy template that our operations team can just configure like once, and then for that client it'll always work. So that's one of the ways that we were able to automate that portion of it. Especially because it's a known cadence, like when our data is going to come in, we have that advantage. So.
And then, is there any correlation between segment size and query response time in your experience?
Yes. So so it actually depends on the kind of queries that we're running. So we ran different experiments on. So we originally went with like, let's just keep the query sizes to like a certain number of rows. And that worked for most of the cases, but then for some of our like outputs, it was just completely slow. So what we would have to do is we actually change that max rows per segment down. But usually what we found is we can actually increase that max rows per segment for majority of our use cases to like around 5 million rows to 10 million rows, depending on like what output it is and how much data we're getting. Because I didn't really cover this, but all the data that's coming in, it's in one cluster, so it's multi-tenant, but it's not multi-tenant in the sense that we're pushing all this data into one data source. So it actually varies by client, and that's part of the ingestion spec. So some testing is done at the beginning whenever we're ingesting a client, and then we have like some good defaults that work out of the box. But then just to meet our SLAs, we would increase that or decrease it depending on what view that they're looking at.
And we have two questions about multi-tenant architectures that came in at the same time.
Okay.
So how are you, do you use a shared cluster for your client, or do you use one cluster per customers? If
Okay.
you share them all in the same, do you keep people on different data sources? Can you talk to a little bit about that setup?
Yes, so I didn't really cover this portion of it. So we're now transitioning into using Imply. But before we would architecture we were running Druid in like K8. So different, each client had like their own cluster. But just because we wanted to get to speed to market really quick, we went with Imply just because they had a lot of things out of the box that we just didn't want to deal with because we wanted to actually do some development. And so whenever we made that switch, one of the questions that came up was, is it better to have like different clusters per client? Um, and no, it doesn't really matter. It only matters in the sense that if we have a contract where we have to have a different cluster just because our client asked for it, sure, go ahead, they'll pay for it. But we have everything in a shared cluster. But in that shared cluster, all that data is not in one data source just because we haven't found like an appropriate data source that warrants that. So each client has like their own data source separated, and then we manage that access through like Druid roles, and that's how we can make sure that clients don't see other clients' data.
Awesome. I think that is it for the questions. So again, thank you so much for your time and the wonderful presentation. Really appreciate you taking the time to do this and put this together. It's super interesting. And thank everybody out there for all your questions. Links to the slides and the recording will come shortly. And remember, if you have a story to tell about Apache Druid and you want to be like Daniel, we can help you share it. So please email community@implia.io or ping us on ASF Slack. Fame, fortune, riches can be yours, or even some pretty good swag. So we set up 5-minute interviews, which actually we did with Daniel a few months ago. Do a blog post, set up a speaking spot in a meetup or in Druid Summit, or we could get you entered on the Powered by page on the Apache Druid site, so apache.druid.org. We would also love to share with you more information on the Apache Druid community activity near you when we can start doing more near you activities. So there's a bunch of places in the community for announcements, ASF Slack, Google Groups, and we are going to be rolling out a new discourse-powered platform for the Druid community very soon. So our next speaker is at the top of the hour. That is in 25 minutes. That is, according to my 11-year-old, perfect amount of time for me to make him a snack. So until then, we'll be listening to Jeremy Plicka, who's the Director of Engineering at Full Contact. He'll be talking about building a real-time eventing engine at Full Contact, and it's not to be missed. So go make yourself or your kid or your spouse a snack, and we will see you in 24 minutes.